Now, this is probably the most important section that we're reviewing, and it's about factoring, mostly factoring polynomials. But it will be short because I have way more videos if you're rusty and you need to look at things in greater details. So I'm just going to go over the different techniques for factoring polynomials, especially factoring quadratic polynomials. Quadratic polynomials are polynomials of degree 2. Now, the first technique of all is taking the greatest common factor. Factoring out the greatest common factor. I'm going to give you an example where it's actually a polynomial of many variables. So this is a y plus 90x squared, right? That's a 9. Y squared minus 42x squared yz. And the how do you factor the greatest common factor? The greatest common factor is a factor that's common to all the terms and that includes as much stuff as we can. Okay, so let's look at the constant first. Like we've got 12, 90, 42. So let's look at the greatest common factor of those numbers, right? So you want to look at the greatest common factor of 12, 90, 42. What is that? You need to find a number that fits into those. So what would you do? You would look at the factors of the prime factors of each, right? 12 is what? It's 2, and then this is 2 times 6, so 6 you can divide by 2 again, and after that you get 3. So 12 is 2 times 2 times 3. So that's how it's decomposed into prime factors. 90 is it's 2 times 45. Now 45 is 5 times 9, so 9 is 3 times 3. And finally, maybe here 42 is 6 times 7, so 2 times 3 times 7. Okay, and then what's the greatest common factor? You have to see what's common to all these numbers. Well, clearly there's a 2 that's common to all of them. Is there a 3 that's common to all of them? Yes, 3, 3, 3, and that's it, right? For example, 7 is not common to all of them. So 6 is the greatest common factor. Okay, so it's going to be 6 times... and then we look at, and this is easier, we're going to look at the powers of x. I've got x to the 4 in the first term, x squared. So there's definitely an x squared that fits into them. And for y, it's y cubed, y squared, y. I can fit a y into them. And the z is not common to all of them. So you can see for the powers, essentially you pull out the lowest power of a number or a variable that's common to all terms. So if you do this here, you're going to get 2. You're going to be left with 2x squared y squared. So you have to make sure that when you remultiply, you should be getting back, for example, this term. So does that work? 12x4 y cubed. Okay, that works. Okay, so after that, 6 times what is 90? 6 times 15. X squared is already taken out. I take out one factor of y, so I'm left with 1y. 42, I'm left with a 7. X squared is gone, y is gone, z, like that. Okay, and then you could try to see, can I factor this some more with using some other technique? But here we're going to stop. So that's the greatest common factor. After that, we're going to focus on quadratic polynomials and see how those factor. Okay, what are quadratic polynomials? Those are polynomials of the form ax squared plus bx plus c. Okay, and there are different cases for applying factoring technique. First case is case 1. We're going to say case 1 where the leading coefficient is 1. Oh, notice that if you have small polynomials, instead of a 2, a 1, a 0, for the coefficients, you could use the first letters of the alphabet, ABC, that works. So example 1, I want to factor x squared plus 2x minus 15. Now I'm not going to explain how the techniques, why they work. I'm just going to apply them, okay? So if you want to figure out why they work, you'd have to look at the videos from the previous course I'm going to link on the Moodle page. So the strategy here is to find two numbers that multiply to the last multiply to the constant term, let's say. So here minus 15, and which add up to the middle term, 2. Okay, so it's going to be, so how do we do that? We look at, for products, it's going to be two numbers. We can list the factors of 15. So 1, 15, 3, 5, and then that's it. Okay, and if the product is minus 15, one of them must be a negative. So when we add them, it's essentially doing like a subtraction of the factors of 15. So if I do 15 minus 1, I'm not going to get 2. If I do 5 minus 3, oh, that works. I'm going to get 2. So the numbers I'm looking for are minus 5 and, no, actually the other way around, 5 and minus 3. Okay, and when you find those, that's it. Okay, it's going to be, so those are usually sometimes called P and Q. Okay, so we could say P is 5 and Q is minus 3. And when you factor it, it's going to be X plus P, X plus Q. So I write this here so that you understand that I'm applying some sort of a formula here. Okay, but ultimately when you write down your answer, you can write this or even skip immediately to the last step. X plus minus 3, that's X minus 3, like that. So that's our answer. So ultimately we could do this in one step, like start with the initial expression and poof, we find the two numbers and we factor. Super fast. Example 2, I've got 9x cubed minus 63x squared plus 54x. That's not a quadratic polynomial, but okay, I wrote this here so that you have to remember that the first technique you try to apply, no matter what the polynomial is the greatest common factor. So we're going to see, is there a greatest common factor here? 9, 63, 54. Everyone realizes that those are multiples of 9, so I can pull out a 9. And I can pull out an x. And if I do this, I get x squared minus 7x plus 6. And now, in the bracket, I've got a quadratic polynomial with a leading coefficient of 1, so I can apply our trick. So I want what? I want a product of 6 and a sum of minus 7. So now the sum is minus 7, and the product is positive. The two numbers I'm looking for are negative. Okay, a negative times a negative will give you a positive product, but a negative sum. So if I list here again the factors of 6 so they're both going to be negative. The two numbers are looking for, and need to add up to minus 7. So it's going to be minus 1 and minus 6. So those are P and Q. So P is minus 1, Q minus 6. So it's going to be 9x, x plus minus 1, x plus minus 6. Once you get comfortable, you can immediately write 9x, x minus 1, x minus 6. Now, case 2. What if a is not 1? Okay, so example 1. I've got 5x squared plus 7x minus 6. As you can see, 5x squared, so the leading coefficient is 5. So here, there's still a product sum sort of technique. Product now, okay, let me try to explain this. This is of the form ax squared plus bx plus c. So the product is a times c. So it's the leading coefficient times the constant coefficient. So 5 times minus 6 minus 30. So we're looking for a product of minus 30. The sum is still the middle coefficient, so 7. So product is minus 30, so it means one's positive, one's negative. So we're looking for two factors of 30 that have a difference of 7. So let's think about this. 10 and 3 have a difference of 7. Which is it, minus 10 and 3 or 3 and minus 10? Well, the sum is 7. So one of them, the largest one, is positive. So P is 10 and Q is negative 3. That works, right? Product of minus 30, sum of 7. And what you do now is you're going to split. So that's not going to give us here, we can't use the shortcut we had before. We can't write x plus 10, x plus minus 3. That's not going to work, right? If I multiply x and x together, I'm going to get x squared and not 5x. So that would be a mistake. So the technique says that when the coefficient is not 1, now we're going to split our middle term using our numbers 10 and minus 3. So we're going to write 7x as 10x minus 3x, right? So since 10 and minus 3 add up to 7, I can split the 7 into 10 plus minus 3 like this. And then I do what's called factor by grouping. So I have 4 terms now. I'm going to group the terms pairwise. So I'm going to think of it as 5 plus 10x plus another sum of terms like this, and I'm going to factor each of them. So I can pull out 5x here, and I'm left with 5x times x plus 2. And here, if I did my job correctly with the number that I've chosen, I should end up with a factor of x minus 2 with the other pair of terms. So I can pull out a minus 3, and I get x plus 2. So overall, what do I get? I get x plus 2. See this x plus 2, that's a common factor. So I'm going to factor that. What's left is 5x plus minus 3. In other words, it's x plus 2 times 5x minus 3. And that's my final answer. If I remultiply this, I should end up with the original polynomial. And you can see now if I multiply 5x with x, I'm going to get 5x squared. So at least it's a good start. Okay. Second example, 16x squared minus 48x plus 36. Now if I start multiplying a with c, I'm going to get a pretty large number. So you want to avoid this as much as possible. So first thing is greatest common factor. Let's see if we can do something here. 16, 48, 36. Those are all multiples of 4. And then 9 has nothing in common with 4. So here I'm kind of done. But now I'm going to look for, we'll try to apply the product sum method. Product of 4 times 9, so 36. And a sum of minus 12. Which means that I have 2 negative numbers multiplied together because the sum is negative and the product is positive. So those numbers are what? Minus 6 and minus 6. Now when I have 2 identical numbers, okay, I can keep on going and split the middle term and factor by grouping, but that actually means I'm dealing with a perfect square. So it's not going to be a surprise in the end that I get a perfect square. And I'm going to show you there's a shortcut in this case. But let's say I don't notice that I have the same numbers, so I'm just going to split my middle term, factor by grouping. Okay, so pair them essentially, right? So it's 4x squared minus 6x plus minus 6x plus 9, like that. I pair them. I factor each pair, so I can pull out a 2 and an x. I'm left with 2x minus 3. If I do my job correctly, if I did my job correctly selecting the numbers here, if those are correct, I should get a 2x minus 3. Okay, and so my goal is to get something times 2x minus 3. So what do I factor? I need to factor minus 3 to accomplish this. Yeah, that works. So it's going to be 4 times 2x minus 3 times 2x minus 3. So you see I have a factor of 2x minus 3 that's common in my factorization. So it's 2x minus 3 squared. Now what I was telling you is over here, if I see that I have the same numbers here, I'm dealing with a perfect square. So if I go back and look at this, this is something that can be written in the form ax squared minus, here there's a minus, minus 2ab plus b squared. And after factoring, this should be a minus b squared. So if I can identify what a and b are correctly, I'm good. So 4x squared is, if it's a squared, it means that a is 2x, right? 2x squared. 9 is 3 squared. So if that's a perfect square, this should be 2 times 2x times 3. Let's check. 2 times 3x times 3 is indeed 12. So actually there's a minus sign here. So you see this is really ax squared minus 2ab plus b squared. So it's going to factor it as a minus b squared. So a being 2x minus b being 3 squared. And I'm done. See, it's a bit faster. An example 4. Is it example 4? No, it's example 3. Example 3, if I've got this. So here, if I want to apply the sum product method, I would need a middle term, right, to figure out what my the coefficient of the middle term is. So I'd have to create it by putting 0x squared. And then I would say the product is minus 36 and the sum is 0. And that if the sum is 0, one number is the opposite of the other. So it would be 6 and minus 6. Okay. And well, there's no x squared here. It's just 0x minus 6x minus 4. You factor by grouping, you get, well, actually I'm going to write it here below. You factor by grouping, so you take out a 3x, and you've got 3x plus 2. And my goal is to get 3x plus 2 in the other pair, so I'm going to take out a minus 2, 3x plus 2. And overall, what do I get? I get 3x plus 2 times 3x minus 2. So actually, you see the factors are almost the same except for the difference in sign between them. And that should remind you of a plus b times a minus b. And we know that this gives us a difference of squares, right? So if I actually notice from the start, okay, it's a lot faster. So if I go back here, if I notice that I'm dealing with something squared minus something else squared, factoring is going to be super easy by applying this rule here. So 9x squared, that's 3x squared, and 4 is 2 squared, and then I see, oh yeah, that's a minus b, a squared minus b squared. So by factoring, I get a plus b times a minus b. So it's a lot faster if you notice this. Okay, so you see those shortcuts that we have for multiplying, we've got them for factoring as well. But if we don't notice it, it's okay. We can still apply the product sum method and it will get us out of trouble. Okay, if we don't notice it's the perfect square or a difference of squares, we can still apply it. It's going to work. It's just going to take us more time.